you, Sam, for organizing this great meetup. My name is Hong. I'm the data handyman at the video blog. So today, I'm going to tell you our story of selling with Docker in production for more than 6 months already. So hopefully, I want to tell you the story like this. Happy selling with Docker. But I think this is more like a situation. All right. So before I read any story, I always like to know the context around it, because devil always hides in those details. So for example, like the procedure works well for a 5-people team, it probably doesn't work well for 50 people. Or like some tools that works well for Twitter or Facebook, more than often, it doesn't work for my company. Because of the team size and the data size is very different, so different trade-offs are made. I think one of a very good example is the Imitation Game. Now you go watch that movie. So in that movie, we'll see Alan Turing. He is the father of the computation theory. And this is the theory all the computer science students need to learn. So in that movie, he used this theory to build this machine to decipher the German Enigma engine. It works in theory, but in reality it's useless because it takes 2 years to finish the decoding. So why? Because in that case, in Alan Turing's built-for computation theory, the running time is not his concern. So that's why we often find the case. Like we often want to find this closed-form solution, the analytical solution that can be proved mathematically. Right? It's so beautiful, it gives us the feeling of divineness. But the real-world problem is often too hairy to be solved just by the analytic solution. So what we do, if you look at the movie, you will see Turing, he has to find every time when he got the code, because the German soldier, they always have Heil Hitler at the beginning of every communication. So with that context, he can use it to reduce hugely on the computation time. So that's why he can decipher the code within the reasonable amount of time. Then he can use it, and it can be useful. So that gives us an example. When the things doesn't work, often for the analytic solution, we have to go for the numerical method. By using numerical method, we have to find the context, right? The Alan Turing's all this context is not in the computation theory. This is ugly, and it only works for that particular case. But it's critical to make things useful. So here I am, I want to set the stage for this talk. So this is the story about trade-offs. So I'm going to show you what analytic solution I'm trying to find that the Docker setup that should work for all the situation, work for 5 servers all the way to 50,000 servers. But in reality, there are several technology limitations of our time we still cannot achieve. So we have to find some context, find some boundaries. Therefore, we can find this local minimum, like this trade-off composed to a solution that only works for our particular situation. And I'm going to show you that example so you can use it. With this context, you can use it with your own situation. So enough context. Let's jump into some data. So I'm working at a video blog. It's a media company. So our goal is to make the creative content for everyone that can afford. Since 2011, we saved more than $5 billion for our customers, and we reached 1 million clips of inventories and 1 million marketplace sales faster than any company in the history. So we have 15 engineers and totally about 65 employees. We have about 9 million requests per day, peak at 300 requests per second. And we deploy about like 3 times a week. So with all this context, the takeaway is we've been there since 2011. So we probably have some legacy system, and we need to migrate. And we have this amount of revenue, and we have this amount of customer using our system. So we cannot say just like rebuild everything from scratch. And our engineering team is relatively small. So we can go, we have different trade-offs with 15 engineering team. We can go fast, and there's something we can do, we cannot do. So about me, I'm the data engineer at Video Blocks. I own this blog domain. It's called codingphilosophy.com. The reason I make my domain name this way is because I often find this philosophical meaning when I'm writing code and when I'm writing design the information system, or when I'm learning machine learning algorithm. So I like this coding philosophy kind of concept. And I'm also the organizer of DC Scala meetup. So and here I'm going to tell you like our next meetup is March 23rd. So in Ruston, anyone who loves Scala, please come to this meetup. And this thing is a little bit controversial to say, but it's truly me. So unlike a lot of people, who's afraid Donald Trump is going to take over the world, I'm even more afraid JavaScript is going to. Yeah, I mean this also give you a good amount of context around me, about me. So I know there are a lot of great software engineers. They are like fast thinkers. They like build, break, and build. They can debug and they can find out problem and they can code really, really fast. And those people, I think JavaScript is a great tool for them. But for me, I like Scala. I like this compiled language. So I like spend time to design, find the right type, so it can prevent me to shoot myself in the foot. And I like to think and then build, and of course it will break. But I like to think, then build and break. Much slower iteration. I often find like that's more my niche. That's why I can build a good system in this way. Different people like different methods. This is how I do it. All right, enough context. Let's jump into the real thing. So once upon a time, before we're using Docker, here is what we have. We already have a decent amount of customer running on this infrastructure. So we have web server, we have Redis, we have MySQL servers, and we have the firewall and load balancer, all managed by Rackspace. So we basically give them, anytime we need a new server, we give them a call, and they will provision it, they will manage it for us. And they handle this DDoS protection, everything. We use GitHub for our source control. And we use Circle CI to work with GitHub. Every time when we check in, Circle CI will pull and run the unit test. And if it passed, we can merge develop, go from master. Then we also have the Selenium. We have the home-built tools that use Selenium to run the integration test. So once the Circle CI and Selenium passed, then we use the Capistrano that built by Rackspace that help us to deploy to our server. And we use the New Relic for the in-app monitoring. And we use that mainly for a lot for debugging. So that's this whole thing that we use for before we're using Docker. Then you might ask, seems working very well. Why do we want to jump into Docker? So I think the main reason is our team grows. So our team grows from one software engineer about 2-3 years ago, all the way to 15 engineers. So with this scale of the team, every time if we want to do something, we want to add a team member, we want to do anything relating to operation, we need to create a ticket for Rackspace. Doesn't work. We need to be able to own that DevOps by our team so we can move fast. That's the main reason. I think we're going to find a better DevOps solution. So that's why we're looking at Docker, and we use Docker, and we like it. So first, let's talk about our goals. What we want to design this new system. What's our goal? This is the analytic solution I'm going to talk about. Like, what can we do? First, we want our local dev is exactly the same to the production. See this 3 equal sign? That's for my Node.js friend. So, and we want to be able to set environment with just one command. What does that mean? That means on my local machine, I can just say Docker compose, boom, the whole production exactly like system is on my machine. And also, I can do the same thing for testing, for the staging environment, and also for the production environment. So this is really just like the push button deploy. I can just run one command, and I can deploy the new version to production. That's the push button deployment. Now, of course, they need to be resilient. It means we're using cloud, we're using AWS. Any server can die. The server died, you need to be able to automatically create a new one, and they need to be cross the availability zone, so it's resilient. And more than that, we also want to be auto-scale. We want to say, when we have more requests, launch more EC2 instance for it. And when we don't, then shut it down. I say EC2 instance, but in theory, in the dream, it should be launch more container with it. Well, we have a container cluster, and we just drop more computation containers that can handle more requests. And I think this is very important when you have more than 10 machines. You need to have central logging, you need to have central monitoring, and you all have all this in-app customized metrics you want to send out. It all need to be centralized. There's no SSH to the machine anymore, like to look at these things. It has to be centralized. The important is it's composable. You don't want to be locked down by certain log servers like Loggly or Logic. You want to be able to switch very easily. Or monitoring like New Relic. If in the future want to use App Dynamic, it should be pluggable. We can switch very easily. That means the interface needs to be common. It has to be standard out or HTTP, the interface that everyone will support. So we want to add new service with just one config file. As long as I can define what's the entry point and how many containers I need and what's the scaling and resilient policy, define everything in a configuration file, I can just launch a new service like that, plus my build Docker container. And of course, security is very important. It needs to be impenetrable. And hopefully it can be cloud independent, right? It's Docker. So we want to be able to easily to switch to any cloud provider we want. And in the future, if AWS decides to shut down, we can, without any effort, move it to any other new cloud provider. Again, this is the goal, this is the dream. So let's list it. So with that, we can actually achieve cost efficient. Maybe AWS is still there. Maybe AWS just become too expensive, and there's a newcomer comes up. We can just try to see. We talk about canary deployment. We're talking about canary cloud provider, right? We try that new startup cloud provider and give us 10% of our traffic to that provider to see how it works. It works great, then yeah, we just move to it, and we can like elastic scale between cloud providers. How good is that? That's awesome. And also, if you talk about cost, nowadays the computation cost is a lot less compared to engineers' cost. Right? Engineer is expensive. So if you can minimize development time, that's actually a more cost saving. So this is what we want to achieve. And here's how we plan to do it. First, we need to Dockerize everything. If you want to go in Docker, Dockerize everything. And we want to run Docker everywhere, on your local machine, on staging, on develop, on production. Run Docker everywhere. And if you want to do the cross-cloud provider, you kind of need additional interface to be allowed you to do that. That's my opinion. So you need a Docker cluster interface that can handle the high availability and handle the auto scaling. And it can read your configuration file to know how to deploy your new service. And it also has the security. So that is what I think is inevitable. And also, this is actually related to what Sam just introduced. I went to actual security, how to handle secret at scale meetup 2 months ago. It was great. And he was my former coworker, so I know him pretty well. He's a very smart guy. So the point is here, I don't know how many people want to raise hand, but how many people check their AWS SS key in GitHub? I did that. That's not the right way to do it, and it makes it very hard to rotate to do anything. So we want to be able to handle credentials with secret management. That can give us more toward this impenetrable security. And this is also my opinion. I believe this log and the metric collection, it needs to be cluster aware. What do I mean by that? So even though your Docker is running in this Docker cluster, but you still need to be able to have a way to talk to the local host. Different people may have different opinion, but in my opinion, to be able to talk to the local host, then you will have this buffer for free, because the local host, you can run the log and the metric collection app that can buffer, for example, just 5 seconds of the data and send it out. It saves a lot of the network traffic, the network overhead. It also, like I said, it's a buffer for free. Otherwise, how do you do that? If you use application like PHP, you cannot say, okay, I have this log, I need to send it locally. And guess what? It's blocking. So your code, your whole app will break if locally server went down. You cannot do that, so you have to have some way to do it asynchronously. You have to do buffer. And yeah, you can have another Docker service that basically just buffer your log and just send it to locally. You can do that. But in my opinion, that creates a lot of internal traffic, which is useless. It will be great. You can just run all these containers, how many containers you want, but you treat your local host as a buffer. Because if your local host goes down, your whole container goes down. So these two things actually live very close together. But it can be a great default buffer. You can just send all these metrics to the local metrics and log tracking system, and you can buffer it, send to the third-party API. This, I think, is a very good use case for the container cluster. All right, so we're talking about cross-cloud provider, right? And it should be trivial, right? It's Docker. Even Microsoft Azure supports it. I don't know if you find this amazing. I find it's pretty amazing because Azure is from Microsoft. Microsoft is using Windows, and Docker is a pure Linux technology. And they even Azure supports it. So all the cloud providers now support it. So in theory, it should be easy to just move around the cloud provider. And if you want to minimize the development time, you want to use the right tool. Okay, so another theory. Let's look at the in practical. How do we do? So I'm going to go one by one of our plan. I'm going to tell you that the differences we face and what's the workaround we do. First, Dockerize everything. So to be able to Dockerize your app, your app needs to be configurable by environment variables. What does that mean? Like your app needs to read environment variables, and so for example, if I have a web app running locally and running in production, they'll talk to different database. The database host name will be different. How do you configure that? You have to use environment variable. That's how you control what's inside the Docker container running. So if you develop your own app, this should be easy. But sometimes it's not easy because if you're using some third-party apps, like we're using Sphinx for search, the Sphinx is very hard to configure those environment. It won't read environment variable, it just uses configuration files. Another better example is New Relic. We have to reinstall New Relic because of this in-app monitoring, but New Relic, it won't be able to control New Relic run or not run by just passing the environment variable. So that will make things kind of complicated. But other than that, for all the application you develop, you should be able to read the environment variable to configure your application, and then you can Dockerize it. So the second thing is not as great as the build time. Sometimes, like when you run Docker build, it first need to pull the base image and like find more often than we want. The Docker hub or the Docker machine is the network issue. It just pull for 5 minutes and didn't do anything. So we have to restart Docker machine. We have to redo it to build it again. Build time, and sometimes it can take longer for the first time. But actually, if you build it second time, Docker did a great job to cache all this intermediate layer. So you need to learn how to write your Docker file in the right way. For example, if you have apt-get install, you write all that into one command. That can make that one thing a layer. So if you don't change anything you installed in that command, you have that cache already. So next time you build, it will be faster. So there are several tricks you can do. You can make build time faster. So build time, not so good, but not so bad either. So a lot of people complain about Docker image size. So image size, if you use Ubuntu, by default, it's probably about 200 megabytes. And if you add Java, add a lot of your app to it, it can easily go to 400, 500 megabytes. Nowadays, it shouldn't be a problem. Like if you're in the office network, 500 megabytes, easy. But if you're on a mobile network or if you're working on a train, sometimes we run Docker pull. It takes a long time to pull everything. So one workaround is use Alpine. Alpine is a very small Linux. But based on our experience, we feel like if you're using Alpine, a lot of time we will just run Docker, exec, and bash into that container to see what exactly is running. And we're debugging right in there. By using this minimum Linux, it's going to make that process very painful because you don't have a lot of stuff you expect from Linux to be able to do debug. So in Docker version, right? Docker version update almost every month. Like every month there's a new version come out. So in that case, the image I built for my machine uses 1.9. Running on 1.8 and running on 110 should be okay in theory, but I would prefer like we have a build machine that has the official Docker version that we're using right now in staging and in production, and we just use that as our official build machine to build this Docker image, and we just use that to run on all our machines. So this is the most important thing. You cannot have stay in Docker image, not right now. So I can share with you this story. So what we want to do is, originally we had this we're using MySQL in production, and for local development, we want to say, okay, Docker compose, run, and just run everything. That means our MySQL Docker image need to have the seed data in there already. So what we end up doing is we use the default MySQL Docker image, and we add the seed data. We rebuild that Docker image. That whole thing become 2 GB of Docker image. And we push it 2 GB around the border. So, but we can pull and we can run. But so you need to know that Docker is using AUFS underneath. It's not very good for the keep updating the data. So if you use database that way, like what we did, our MySQL container crashes all the time. So we have to give away that approach. So we find another way to put the state is, okay, we start the default MySQL container, and we run the build script to load all this data into that MySQL container. In this way, it's a lot more stable. But again, it has the other trade-off. So your Docker Compose no longer work by default. When you launch all the service, you have to say, okay, restart some of the index job, run some index job after that. That's the trade-off we have to make. But right now, if you have state in your Docker image, it's first not recommend by official, by everyone. Second, by our real case, it actually crashes all the time. So a fix for that, which is still 0.1 alpha right now, is using Flocker. Flocker is a service that basically manages your volume as the container. So what you will end up with, you have a code container. Right? You have a code image that you will run the code. And you can link with this Flocker volume container. You can pull from the volume hub, get your data, so you can have your C data, And in the future, you will have your production data and everything just snapshot every hour, and you can easily to go back to the state of time and pull this. You have code and state pull together. That will make your whole Docker container run. But this, again, is 0.1 alpha. It's not ready yet. So overall, I think Dockerize everything is solved. Like, you should Dockerize all your app, because by doing that, you will have your app running in the exact same configuration you config. For example, if you use Node.js, not saying why, but if you use Node.js, Node.js, you have like 0.10, you have 4.2, 4.3, and 5 point something is out. So all these different versions, you have no way to control it if you don't use Docker. By using Docker, you can control your environment. So you need to read from environment variables, and you have paid a little bit build time situation. But I think it's worth it. Docker already improved a lot on all this problem I list here. So you should Dockerize everything. So with that, I'm going to show you an example. What's the benefit of Dockerize everything? So this is called Stagehand. It's built by one of our engineers. It's pretty cool. Okay, so here's what we can do. Since all our things is we Dockerize everything. So what we really can do is here list all our GitHub repository. Yeah. So I can just click one button, say yes, 2 buttons, and it starts to initialize. What it does is it runs an EC2 instance, and it runs Docker Compose to pull everything to that instance and start it. And this way, we can easily to just show our product team and show our CS team like what exactly is in our branch. So we have a feature branch, and we code everything there, but it's not ready to merge to develop yet. But people want to see it, and people want to test it. How do you do it? We can just come here and just click one button. We'll launch the whole environment. So we can just a QA team, CS team, they can look at it, see exactly what's going on. It speeds up a lot of our feedback loop. So this is, if you Dockerize everything, you can, this whole thing is powered by Docker. You have, without using Docker, as you can see, you need to set up all these tools. It becomes very hairy to be able to manage. So again, we'll let it run, and then we can come back to see the result. It takes probably about 3-4 minutes to finish. Not too bad.
Can I ask you a question?
Sure.
So when you hit play, is it spinning up a new EC2 instance, or are
Yes.
you using Capstrano to just push it out to an existing instance?
We're not using Capstrano anymore.
Oh, okay.
So
sorry.
when I click, it will launch with the base AMI. The base AMI has
Okay.
Docker and NTP, only these two installed, and it has Docker Compose. Yeah. So then you can run Docker Compose. Basically, it will set up a local dev environment, and it takes HTTP requests, so all the company team, they can see what's exactly going on with your branch.
Cool.
The real code. All right. So second thing we plan to do is we want to run Docker everywhere. Right? But I think that people often forget, like, run Docker everywhere, what does that mean? Docker is a Linux-only technology. So if you want to run Docker everywhere, it means you need to have Linux on your machine. That actually has a lot of pain point around it. So on my Mac, I have to have the VirtualBox running, and I just need to restart and sometimes, because I often just close my notebook and go, and when I come back, it works most of the time, but sometimes, since it's a virtual machine running on your native OS, you need to restart, repull, some glitches around that. And it also means that you cannot run Docker on things that are not powerful enough for the virtual machine. Like you cannot run Docker on your cell phone. You cannot run Docker on tablet. this is something if we can solve, that will be, there will be a lot of great implementation if we can fix this technology limitation. So I already mentioned about this. You need to restart, you need to clean up, especially since it's a virtual machine, it doesn't, you probably only allocate at the beginning 20 gig of the disk drive for this virtual machine. Then once you accumulate a lot of Docker images, you need to clean it up. Not too bad, just something you have to do. And the other thing is, if you really run Docker everywhere, like the benefit of PHP is gone. People who like to code with PHP is like they want to write code and you can see it run immediately. Like if you want to say, okay, I want to build the image and run it, even the build time is very fast, you kind of turn PHP into Java, right? Turn it into a compile language. You need to compile into this artifact, this Docker image to be able to run. So which is not acceptable for a lot of PHP developers. So to be able to work around that, we have to build this called like our environment image. So which it has the whole environment, it running, and it mount our our local code directory. So you actually use that local code directory, mount that. So with that setup, you can still run Docker, and you can change your local file. It will read that, and you can show on your development environment. That works great, except it doesn't really work for IDE. So our goal is for new engineers joining the team, you can just say, okay, here's your laptop, run Docker, you should have everything set up. Yes, if it has Docker, run Docker, yeah, and you need to add the C data. But after you add the C data, everything is up. But open, you want to use IDE like IntelliJ, you want to run some debugger to, if you really want to do development. And at that time, then you still end up need to install PHP on your local machine, because I know IntelliJ is talking about like how to use the PHP binary file inside a Docker container. But as far as I know, it doesn't work well for me. So right now, for our case, you still need to install like PHP binary file, PHP debugger to be able to, for your IDE, like IntelliJ, to be able to use it. There's like production-only tools. For example, we only want to run New Relic in production for the reason of cost. And this New Relic you cannot control by the environment variable, so we have to build this special prod-only edition that we install New Relic. So our image we have an environment image that's for local development, and we have this with code that we run in the testing environment, we run with the staging environment, and finally we need to build another one which has the New Relic. That's what we run in production environment. This is, yeah, it would be great like if we can just have one base image run everywhere, but this is what it is.
So are you baking like a New Relic agent into your image then? Is that what you're doing?
I believe that's the only way you can make New Relic running. So in the following slide, I'm going to talk about, like, ideally, what would be great if you can do this in-app tracking like this cluster aware. So you just install on your cluster local host, and you can send all these metrics into that local tracking app tracking system and just send out to New Relic. But currently, I don't think that's possible. You have to install your New Relic agent inside your image. That's the only way to do it with New Relic.
Okay.
And other in-app monitoring tool that I try with. So another very painful thing is how do you handle stateful service, like your database or your Elasticsearch. This way, I already show you how do we handle in our local dev, but in production, I don't think Docker is ready for me to run just MySQL Docker and then just have that stay managed with Docker. It's very dangerous. So what we want, I don't think Docker is ready for that. So what I end up doing is I'm using RDS in the production. So all our stateful service we handle now with Docker. Then, but later on I'm going to talk about, so in the Container Summit this year, they are talking about how to use Flocker and then to create snapshot of your database image and doing that way. So how can they achieve the RDS level secure, the resilient like database service by just using Docker, which is very interesting. I would love to try it. But when we do it, it's not ready. We cannot use that. And like I mentioned, the Docker Compose can be more programmable. What we want to do is we want to launch this default MySQL Docker container, and we want to install the C data. And after that, we want to launch our search service and want to say, can we do the indexing, that things. We want to compose everything into one command, one Docker Compose command, instead of Docker Compose and install C data, then run index. Everything, Docker Compose, if Docker Compose can support that programmable way, that will make our life easier. So when we use Docker, what we found is if you use like T2 instance, for small instance, you will have glitch like CPU, or sometimes your app your container just crashed, and it happens like rarely, but it's kind of annoying. Like sometimes, oh, your Docker doesn't run, and you have to look at it, just run it again, it works. So things like kind of this glitch is a lot better nowadays, but still, that's the key point we had. Additionally, Docker has new versions every month, so you have to upgrade your whole environment with the new Docker version. That's just how it is. Docker is a fast-moving technology, so we have to deal with it. So like I mentioned, I want to have this Docker cluster as an interface to be able to allow me to do cross-cloud provider deployment. So at the time, we look at several things. So Apache Mesos and Chorus Fleet. Apache Mesos, the thing is hard to manage. As I mentioned, we have 15 people team. It probably makes sense for a bigger team that can dedicate to manage this Mesos cluster. But for us, we want to get it running fast. We don't want to add another technology. We need to like really spend a lot of resource to master, to understand that. So Mesos, we don't do it. Same reason for Fleet. So I saw Paul is here. Paul, I know you have a lot of real-world example using Fleet. Probably can give a good talk on that. But for us, at that time, we don't have this technology. We don't have this knowledge in the team, so we cannot use it. And all the other three things, ECS, Kubernetes, and Docker Swarm, is either like in the preview or in alpha, beta, or whatever, because it's not ready. I remember I tried Kubernetes with the AWS setting. It just won't run. It just failed at the beginning.
Oh, because I did that with Red Hat about 2-3 months ago, where they had Kubernetes running on Amazon. It worked fine. We made changes, sucked it in, and it worked perfectly.
I believe so. So when I checked Kubernetes, Kubernetes is actually my #1 candidate where I want to try to reconsider this Docker cluster. So at the time we were trying, it's about July, August last year.
Yeah, this was after that time.
Yeah, and now it's 1.1. So.
Yeah. And that was working with Red Hat Linux 7.1, which had Docker containers in it, and it worked sweet. I mean, it worked fine.
Kubernetes also has this cluster awareness, which I really like. So this context is around about July, August, back in that days. So it doesn't work. Kubernetes, yeah, at that time I don't think it's 1.0 yet. So it doesn't work well for us. So what we end up doing is we have this EC2 instance, and we have multiple containers running. So this Webpack container is our PHP code. And we have Fluentd. Fluentd is our tracking system to track all these in-app metrics. And we have Logly to track all the log. So all this running as a container. So as you can see in the code side here, this is the Ansible code. It will be translated into the cloud init script running on EC2. So what it does is AWS will launch this EC2 instance and immediately will run this Docker run command. So as you can see, each Docker run command basically create this container. And pay attention to this highlight code. So what we did is we got the host IP. So by using the host IP, and there's a log driver syslog, and you can pass your syslog address. And you can see locally listen to 514, port 514. So with that, you can allow the web container to be able to talk to your FluentD container and talk to your locally container. So with this case, we no longer need to use Ansible or Chef or any CM tools to install apps on your machine. What we need to do is we just launch this EC2 instance, and with this Cloud Init script, it set up everything.
Have you looked at Swarm? Because Docker Containers is saying to use Swarm now.
Yes.
Okay.
So Swarm is here.
Okay.
Docker Swarm, I'm positive at that time Docker Swarm is about beta.
Yeah, well, they would Docker would talk about a month ago.
Mhm.
Haven't heard anything about it.
Yeah. So this is our infrastructure of one service. What we have is we have Route 53. Basically, it's just alias for a better name. So what you can see here, like you see this the side with RDS.internal, with Sphinx.internal. All this is the Route 53 name. It points to a ELB. Nice. So it points to this ELB, and from ELB we have this auto scaling group behind it. So this auto scaling group basically handles this high availability and auto scaling for us. And from there, it can talk to the Redis cluster, and all these things is inside the VPC. There's no reason we cannot put, you cannot put the RDS within the VPC. But for our case, we have some legacy system that read data from production database and slave it and do some analytics job behind the scene. So for our case, it will be easier if it's not within the VPC. So we put the RDS outside of VPC, and this is the Kinesis fire host. So from the EC2 instance, as you can see, the FluentD will just buffer the data, send everything to Kinesis fire host. So this is our setting. It has the security because things are in the VPC, and it can auto scale. It also has high availability. And then pay attention to this auto scaling group. So every time when we deploy a new code, we create a new auto scaling group and register with the ELB. So by doing this way, we have several benefits. First, if you change the ELB, then that means you change your DNS. Your DNS time to live you can set up to 5 seconds or 30 seconds, but still, it's up to the client to respect that TTL. So you always have a long tail of the DNS. But by doing that, since we changed the auto scaling group behind the ELB remains always the same. So that long tail thing issue gone. And it's maybe more expensive to do than the routing update. So what do we mean rolling update? Rolling update means within the same ASG, you just add a new one and retire the old one, add a new one again, retire the old one, and just keep doing that. So at that time, you don't have a lot of duplication. So for example, if this ASG has 20 servers, that means you need to launch another one has 20 servers. And you have, at the same time, you have 40 servers running. And once you see everything works fine, then you can kill that. So that's what I mean. It may be more expensive than rolling update. But what you got back is you can instant roll back. Rolling update, okay, you say, oh, I want to run this. When you see the issue, you don't know how many % you're already rolling out, and you need to roll back. In my opinion, I think that's more hairy. Right now, I have exactly 2 auto scaling group on the ELB. I can easily to say, okay, I want which one. If the new environment is bad, I can easily switch back to exact old code and old environment. So for example, the reason is not because of I have bad code. The reason is because I update the Docker to 1.10 and it has issues with our existing system. In that case, I still can go back to exactly the same machine because that EC2 machine has the Docker version that's not changed yet. But I think for any of the real-time update, that means you take no downtime. You want to update your system. Like DB migration is always like a question I always got asked. Like, how do you do DB migration? How do you do rollback? So my answer here's what I believe, there's no DB migration rollback. You cannot roll back your DB migration unless you like take a snapshot and do all these things. But that means you cannot have the no downtime upgrade, because after you roll out, you have a new customer comes in, you already have data in the database. There's no snapshot for that. So for your database, you can only keep updating. There's no way back. You update your database to the next version first, and that version can work for both code version, and you go from there. So that's also why we do it first. We first run DB migration, and if it failed, then nothing happened. We fix that. After DB migration is done, you can deploy your new code. But at the time, you still have the old code talk to your database. So you need to make sure your DB migration works for the old version. You cannot do like delete column or delete tables. You have to do it at the next time. After you deploy the new code, then you run another DB migration, delete those columns. So wait a minute, like you're not really using Docker. Like you basically just treat it as an AMI. Like, you're not wrong. So by the way we use it, it's not really like running Docker inside a Docker cluster, things like that. But we are using like an AMI 2.0. What does this Docker image better than AMI? First, you can run on developer's laptop. You cannot run AMI on your own laptop. So, and it's built a lot faster because Docker build caches all these intermediate layer. It built, usually if you build AMI, it's like 10 to 15 minutes. Docker build down to minutes. It's a lot smaller and cheaper. And it's composable on a single EC2 instance, which means I want to say no configuration management, like you don't need to use Chef or Ansible at all, but no, it's not. So sometimes if you cannot use, you have to have the Docker installed, and you have to have like NTP, some stuff installed. But with that built in your AMI, then you can just launch it like I showed you in the previous slide. You don't need to set up environment and make sure the environment is correct, those kind of stuff. So let's compare our, so this is the replacement we deal with because we cannot find the viable Docker cluster solution for us. So let's compare to see, does this new method, how does it compare to the original goal? So it has to have availability by the ELB health check. So AWS ELB has this health check. It can, if your EC2 instance goes down, it will launch a new one, pull the Docker image, start the Docker container, runs it, everything was fine. But you want to be careful about the ELB health check. So we run into this issue is, our ELB health check, we check, okay, if the PHP is running. But if originally we set up, oh, if the whole site is running. But you need to think about, like, the whole site is running has a lot of dependencies. If your database has issues, then your site is not running. But your database issue cannot be solved by your auto-scaling group. Launch more instance won't solve your database issue. So this health check you really need to think about is the health check on the instance level, on your Docker container. What's the problem I want to catch? Like I want to retire this instance and launch a new one that can solve. So we end up on the Nginx configuration. We want to make sure the Nginx is running and it can talk to the basic PHP and A back 200. Okay. So with that, if the Nginx goes down or the whole EC2 goes down, sure, we need to retire it and launch a new one. But if the database goes down, we don't want it to do anything because at that time you just keep doing anything. This happens a lot in our staging and testing environment, and sometimes we just don't care because it's staging environment. Let's just really see the whole data, and then you see this autoscaler will keep launching a new instance and killing all instances. So that's the thing you want to be careful about. The second thing is autoscaling is done. It is by autoscaling policy. Same thing. You want to think about what's the problem you can solve by adding more instances. So originally we were thinking, oh, it's great because we can just check the latency. If the latencies go higher than 100 milliseconds, then I want to launch more instances. but your latency may not be solved by adding more instances. If your bottleneck is on the database level, again, adding more instances make it slower. And just keep adding more instances, make it even more slower. So for our case, since we're using PHP, we found the CPU usage is a good indication. It has a strong correlation with the latency, and it's exactly the problem you can solve by launching more instances. So we set up this CloudWatch matrix, and we use that for our scaling policy. It works great. Add a new service one config. This thing is what we cannot achieve, because as you can see, you need this whole you need this whole infrastructure for one service. So you need to update. For us, we use CloudFormation to manage our infrastructure. I'm going to talk about that later. But you need to add this infrastructure for your one service. It's not as easy to just config. Like if you use Kubernetes, you will see you can have just config file, have my scaling policy, have my endpoint, boom, it will run. This won't be able to do that. It's actually a pretty big deal if you want to do microservices. So that's why we're going to test Kubernetes again and try to see how if we can get the cluster, Docker cluster, running production ready. I can give a talk after we try this. I think it will be a very good knowledge sharing with everyone. It has the security, some kind, because the thing is within the VPC. There's no outside connection to it. So that's the whole thing. That's our workaround with the no Docker container available for us. So let's look at, with that workaround, how do we do log and metrics collection? So you can see, we have the cluster awareness. We kind of cheated because it's not really cluster awareness. We only run one main container on one EC2 machine. Of course, it has the cluster awareness, but we still have it. So our app can launch all these in-app metrics and the log to the local, to the locally container, to the Fluentd container, and it can buffer it and send to our service, which works great. And I think, and this all be done by the common interface. So what the common interface, what do I mean by that? It means if you run your Docker container on your local machine, you can see the sender out to see all your log. But if you run it on the staging or in production environment, the locally container can just capture that and just send it to locally. So by this way, it makes our development it's very easy for local development. It's also easy to debug in production. So I think by using this common interface, it gives you a lot of flexibility in the future. If you want to switch log services or you want to switch monitoring or in-app tracking services, it's easy to do. So in my opinion, standard out is the best. HTTP, it's okay. Everyone supports HTTP. Syslog, a lot of log, they use syslog. So I would say, yeah, if you use log service, syslog is fine because it should be support everywhere. But I will fight for the previous two if I have the option. So in-app monitoring, I talk about New Relic is really the pinpoint of this whole Docker selling experience. We have to install different, we have to build another Docker image for it, and it's hard to control, and it won't have this cluster awareness. I hope there's a better way to do it. I'm going to talk about, there's a new tool called Sysdig. It's not as good as New Relic, but hopefully you can get there. So I kind of talk about that. To be able to cross cloud providers, you need this Docker cluster as an interface. You need to be able to handle this scheduling, resource allocation, auto-scaling, discovery. So we cannot do that because we treat it on the Docker cluster approach. And other than that, I think when you need to move across cloud providers, data will be the highest gravity part. Your data will be the hardest one to move around. For example, we have 500 terabyte. I'm trying to get petabyte, gigabyte, terabyte. Yeah, we have 500 terabyte of data. Because we're a media company, we have that many data on S3. Moving that data into different cloud provider is going to be a challenge. It's just how it is. So data will be the high gravity part. So when we really can implement the cloud provider and how to deal with data, that will be another thing. It's a challenging problem to solve. So to be able to use the right tool will make your developer happy and will make things move a lot faster. So what we end up having is this. All the code check into the GitHub, and from there, triggers Circle CI and the Selenium task to make sure everything passed. And if Circle CI passed the test, it will build the image and push into the Docker Hub. And from there, we can use Huba to run command. So if everything is ready, and we can say Huba deploy staging, deploy your new code to the staging environment, and we can do a final manual check on the staging. What Huba does, Slack talk to Huba, and Huba talk to Jenkins. Jenkins is our execution machine. It will execute our Ansible job. Our Ansible is the code I show you on the left-hand side. It will generate that cloud init script. It will launch an EC2 instance, and it will set up the new auto-scaling group, and it will run. So this is our kind of artifact pipeline running with this tool. It does the job. We like it. So that's the end. Finally, we're now going to this stage. So just do a quick review. I know I'm probably running out of time. So what have we achieved? Let's look at that original goal we want to achieve, that dream. So we have the local dev. It's very similar to production. So what I really like is we have Node.js script, and we have Scala application, and we have PHP application. So people who doesn't know about Scala or doesn't know about Node.js, they can just run the production exact same production code on their machine, so they can do their job, because this application talk to each other. So it doesn't need to like figure out how to use N or the SBT to be able to set up a local environment to run. You can just say Docker run this, and he can develop his own part. This is something we really like. But the caveat is, yeah, stable service. Like MySQL container is pain. Hopefully it will be fixed by the Flutter volume hub. We'll see. So we set up environment with one command. We kind of achieved that with Docker Compose, right? And for push button deployment, yeah, we have it. But on local environment, this is what I mean, like half done. You still need to set up the C data, you still need to run the index, things like that. Not perfect, but I would say we're 90% there. We have the resilient and auto scaling. This is powered by, resilient and auto scaling, again, is powered by the AWS service. It's not really like what we built or what we see in the Docker container. Not exactly what we originally want to achieve, but still, we can leverage the AWS service to be able to achieve the resilient and auto scaling. Central logging, monitoring, and metrics. I would say we're 50% there. The main roadblock is in-app monitoring, like New Relic. How to make that work well with Docker is a challenge. And also, if you think about it, New Relic charges you per host. So if you really want to run microservices, you might have some service you just run like a batch job, or you have very small internal service that just for the internal log. If you want to monitor those, you still pay the exact same price, no matter like you have only 500 megabytes of memory, or you have 64 gigabytes of memory. Like this, in my opinion, doesn't make sense. I know there's a lot of in-app monitoring company. They are trying to fix that. So their pricing model is based on how many memory you use on your container. I think that makes more sense, especially if you want to move to the microservices kind of domain. That's that. And compared to what we want to say, add a new service one configuration file, we cannot do it. We have to launch all this AWS infrastructure to do it. That's because we don't have the Docker container. Security. I don't think anyone can check this, but what we have is things are inside the VPC, and we made our own choice to move the RDS out of the VPC, but you definitely don't need to. So everything can be within the VPC. It's secure because it's not accessible. Cloud provider independent, of course not. We really tie on the AWS to give us this resilience and auto scaling and a lot of other things. So we are tied to AWS for now. Cost efficient, somewhat. We have the auto scaling. We can scale our instance up and down based on the different request amount. And we can also use different AWS instance type. So we have a lot of T2 instance because those instances just for internal tools. It has this spikeable kind of behavior. So our cost is not too bad. So cost efficient thing have done. Of course, once we have the Docker cluster, we might be able to save more costs, but not too bad. Minimum development time. Since we start from June, I think it takes us 3 months to have this run in production. So I would say that's a pretty decent development time to just get this whole thing done with Docker and running in production. Again, the big caveat is we cheated, right? We actually are using AWS service to do this resilient and auto scaling. So by making that trade-off, make this huge development time a lot faster because we don't need to spend time to study like CoreOS, Fleet, or missiles, all these Docker container technologies. So what's the limitation we face? We hope it can be better in the future. Like Docker pool issue. Like even now, sometimes when you run Docker pool, it's just unbearably slow. Sometimes it works probably 99% of the time, but sometimes it's just very slow. Sometimes the Docker Hub out of service issue. Sometimes because of the bug. So there's a bug in Docker 1.8, which we have. So sometimes when you pull it, if you have a lot of if you launch a lot of EC2 instances and pull at the same time, it will just hang, and that instance got killed and they need to restart. So that's the pool issue. But I think after 1.9, this thing got fixed, and it's a lot better still. Can be perfect. So running Docker on non-Linux machine is not stable. Again, it's because of the virtual box you're running on your native OS. This is kind of what it is. Docker, at the end, is still a Linux-only technology. To be able to use Docker on Mac OS or to be able to use Docker on Windows, you have to have the virtual machine. Yeah, it'll be great in the future. We find a way, or we make the virtual machine very stable to be able to just run Docker like you really run on your Linux system. So Docker cluster is not ready. I'm not sure if it's ready yet today, but when we try it, it's not ready, or at least it's not easy enough to use for me. Like we want to minimize our development time. We don't have time to spend a lot of time to research on that. But again, like I said, I have high hope on Kubernetes. I feel like Kubernetes will be the thing that can solve this problem, and along the way, it can solve a lot of other problems, which I listed in the previous Go page. So now our tool can be controlled by environment variables. I think this is a shame. Like New Relic, like you cannot say, it doesn't allow environment variable to say it's wrong or not. So I believe with this Docker adoption keep going on, every company, if they want to provide service, they will need to be able to support Docker. By supporting Docker, that means your tool will need to be controlled by environment variables. So I think this will get better eventually, but currently it holds us. It's like a big pain point of our development, like when we need to find a lot of workaround on this issue. So in-app monitoring cannot be outside of containers. Again, this is not only for New Relic, but also for a lot of like AppNet, other in-app monitoring tracking. You have to install that within your image. So I know there's a monitoring tool called Sysdig. It actually you can just install on the host, and it will scan the Docker library and the Docker log file on the host and to be able to send the tracking information. This won't be as detailed as the new relic PHP agent, but it can be good enough because with this matrix collecting plus your error log, I think you should be able to achieve the same debugging by using new relic. So I have I hope the SysDict, I haven't tried it, but I have high hope on it. I hope like SysDict can be the same, like can solve this problem. The in-app tools should be able to outside of the container. So that means I can run all these containers without worrying about like add a new relic. And in the future, if we want to switch out new relic, we need to like change our Docker image to be able to adjust to that. And another pain point we have on new relic, just keep talking bad about new relic. we already have all the steps development done to migrate to PHP 7. And the new relic just won't allow us to because the new relic PHP 7 agent is not ready. So we have to roll back all our change to go back to PHP 5 just because new relic doesn't support. So this is the thing like you really hate. Like you hope like all these things you should be like your common interface. You can be able to track with anything like running on your container cluster. In that way, you don't have all these dependencies that hold you back. So the trade-off we made, CloudFormation. So this is the thing I'm not talking about really quick. About CloudFormation, the trademark is like infrastructure as code. Like what do you, in my opinion, it's really far away from it. So first, your infrastructure has a mutable state. Right? Your infrastructure, like your ELB, your ELB cannot be just go down and up to a new one because that will be a different CNAME. And if you have different CNAME, then your outside traffic, you need to update that. And then DNS has this long tail. So DNS is hard. And if you have your CloudFormation, which is definitely no, definitely not use your CloudFormation to launch your RDS, any stable system, because you cannot afford that. In my opinion, CloudFormation is not really ready for the production use because a lot of time we run into this state like, okay, it cannot update, it cannot roll back, it just dies there in that state, and you have to open an AWS ticket, say, okay, please make it go back to the previous state so I can fix it. That's fine if all your infrastructure is like ASG that or Route 53, that's the thing you can change, you can launch a new one, you don't care. But imagine if that's for your MySQL database, right? You take down your MySQL database means your whole service will be gone. So don't use CloudFormation to manage your database. And CloudFormation also is very ugly. It's really code in JSON. If you look at the CloudFormation code, you will want to jump out of the window. So that's why we use CloudFormation, you might ask. So at the time we look at CloudFormation, there's another tool called Terraform, which a lot of people say good thing about it, but in our opinion, at the time we want to look at ECS, we want to look at ECR, we want to look at a lot of very, very new service. So in our opinion, CloudFormation, since it's from AWS, it will have the latest support from AWS. And Terraform, this open source tool, it's hard to catch up this fast moving AWS. So we that's one of the main decisions we decided to go with CloudFormation. And
but doesn't CloudFormation have to define all the different services with an Amazon Web Service, and then you can reuse it quite over and over again?
Yes.
You define how you want to set up your Docker environment.
It's not really a Docker environment. It's like how do you want to set up your EC2, how you want to set up your VPC.
Yes.
So in our CloudFormation, we start from VPC. We have a VPC, and we have all these ELBs, and set up the Redis cluster, set up RDS cluster.
But as I say, a little bit of time by setting that up, and then it's just repeatable.
Yes, and you can pass your stack name, so that means it's different environment.
And you can just build a Docker container stock with. Okay.
But it's not as easy as it sounds, and it like I said, it has mutable state. So every time when you change, if you cannot successfully update to the new state, you're stuck there. So in my opinion, your infrastructure is more like a database. It has a critical state there. So you should treat it like DB migration. So what's the thing about DB migration? There's no way back. You can only keep updating. So you keep updating, keep updating, keep updating. In my opinion, what I like the most is if I can write all this AWS command to just update from a certain state, I can keep updating it. So in the future, I can repeat from this state and with all this AWS command change, so I can reach my current state. But then you will reach out to a situation like, oh, or your original state has like 3 databases and you want to delete and you want to create a new one. Then why do you need to go through all these things? It's not like a code. Like this whole thing might take a couple hours to run. So it would be great if you can take a snapshot. I can run all this migration. It's really like database. I have an initial C data. I run all this migration, and I take a snapshot to have another C data and go from there. That's why I hope CloudFormation in the future it can do, but currently it cannot do that. So be careful of using CloudFormation. There's a lot of caveat, there's a lot of pain point we have. Just want to share with everyone. So we have to duplicate Docker images because the environment, if you run locally, you don't want to build Docker image every time. So we need to have this environment-based Docker image that you run locally, so you can change your local file system and you can see the change for PHP part. If you are using Java, you already need to build and run. You might be able to be okay with it, but for PHP developer, it's not. So we have to duplicate Docker images for New Relic and for the development speed. That's the thing. And you might need to use Alpine to reduce the image size. In my experience, I feel that's even more painful for the problem you're trying to solve. Like, yeah, your image speed reduced to under 100 megabytes, but anytime when you need to debug, you pay a lot of price for that. That's my experience. So this is the last one. I kind of covered this already. The new bright future, what's the hope? The hope first is Docker content cluster is finally ready. We'll find out. I have high hope on Kubernetes, and we'll try, and we'll see. So Docker 1.10 added a lot of networking capabilities. So that means like within the cluster, so with our case, since we're just using Docker as AMI, all our network basically is based on the EC2 level. But if you're really talking about Docker cluster, then in there you can do different things. So you can, if you want to deploy things like Spark, you want to have like a group, placement groups kind of like idea, you can be able to achieve with the new Docker networking capabilities. So that's pretty cool. And what I really hope is the Flocker can grow, mature. So we can use Flocker to handle our state. So we can really have this data volume hub. Then we can pull the code image and can pull the data image together, combined to my Docker container. That would be great because then I can have the C data running there, and every time I update, I just push it to my bottom hub, and all the team, they can just pull, and they have this new C data. That can allow us to achieve like Docker Compose up. Then yeah, you have your production environment. No other command need to run right there in your new laptop. So I mentioned this already. Monitoring tool like Sysdig. The Sysdig is running on local host. It's running on the host machine, and it can scan the Docker process and be able to send out the metrics. Like it can do pretty good things like JVM metrics, things like that by Sysdig. So I really want to try it and see how it works. If we can, use tools more Docker friendly like Sysdig other than New Relic, it can fix a lot of pain points we have. So I already mentioned the final thing, infrastructure management. I want to be able to treat infrastructure really like database. I can take snapshot. Right now in AWS, you kind of have a way to do it. They allow you to run a web app, and you can snap your whole infrastructure and generate the ugliest JSON you have ever seen. Probably like a couple thousand lines, and you need to like delete the thing you don't want and generate it. Yeah, I mean, it's terrible. It's not easy to take a snapshot. It would be great if I can just click all these service. I want to generate a snapshot for now, and then anytime I need to make a change, I just make the AWS command. I check in those AWS command into my code control system, and so I can easily to build the exact same environment like this. But every once in a while when this commit becomes too big or when it doesn't make sense, I can take another snapshot and start from there, like how we manage database. It would be great if we can do that. All right, so that's done. Thanks for listening. Question?
I just had a comment about with Terraform, you can actually use state. So you can actually save off what you run a Terraform template, you can generate what it looks like now. Or you run it again, you can do a plan state so it can tell you exactly what it's going to do. So that might solve your problem. Like
You're talking about like a dry run, so you can.
Yeah, you can do dry runs. You can also take snapshots. You can also build up. You can have multiple templates build off of each other. So you can have a VPC one, which will build off like instances or auto-scaling groups. So that might solve your problem. And you can also use CloudFormation in Terraform. So you can actually, if there's a gap, you can actually just use direct CloudFormation.
That's a great feedback. I think, yeah, that's a good idea. So you're saying if something I only support in CloudFormation, I can use Terraform to run CloudFormation.
You can wrap it in Terraform and run it there. And you get dry runs. And I talked to Armand, the guy that created it. He said that he was on the team that generated, they made CloudFormation, and they said they're never going to have that feature of doing dry runs because they hardcoded the dependencies, so they have to refactor all of it.
That's great. Yeah, I think I heard about a lot of good things about Terraform. Yeah, I'm going to give it a try, especially with this setup. With this setup, it's hard to move to microservices. So we're going to try this cluster container Docker cluster again. See if it works. If it works, it can save us a lot of problem of like doing this with either CloudFormation or Terraform. But if that still doesn't work, we need to refactor our CloudFormation. I definitely will try Terraform again to see how can we clean this up. Currently, we have like 600 lines of JavaScript code. It's not too terrible, but it's still pretty bad. I hope I can optimize it. Other questions?
When you said you Dockerized everything, did you Dockerize also your services to be able to do the continuously with the Jenkins? I presume you have an LDAP server. I presume you have something like that.
We do not have an LDAP server. We haven't Dockerized Jenkins yet. We should, but we didn't.
So all the services around your product aren't Dockerized?
Yes.
The second question is, when you say about building two things, is how much do you care about your delivery patterns in terms of what artifacts you can put inside your container? For example, I presume you said you work with PHP.
Yes.
So I presume it's when you take containers from outside world, do you care to have a standardized image, a standardized base image for all your containers that you deploy?
For PHP, we do. Yes. So we have this base image. That's actually what developers run on their laptop. So that one, it doesn't have the code within it. It only have all the setup environment. So that's the way the PHP developer, they can change their local file system and they can see their change immediately.
So as a consequence, you don't use a package management for your own packages, like you use peer instead of using, I don't know, apt-get to install your own PHP code, for example.
We use apt-get. Yeah, we use apt-get inside the Docker file.
For codes, but not for your own code.
We use Composer. Composer for the packages.
You mean PHP packages?
Yes.
Oh, PHP packages, yeah, we use Composer.
You use Composer for that.
Yes.
It's not the operating system apt-get.
No. apt-get, we use apt-get to install like a PHP, New Relic.
So how many
system.
ways to get content inside your container there are? One is Ansible. Second is Composer. Third is apt-get.
We don't use
Fourth is probably curl.
curl, yeah.
So
I believe we have something using curl to install, but we don't have Ansible. We're not using Ansible inside our Docker build file to install image. So we have apt-get and we have Composer. I believe we have curl to install some service.
So from security point of view, do you care about these distributions way where your content gets from?
That's a great question. Yeah, we should care. How to put it this way? So, to be able to fix that, you need to have your own artifact repository, and you kind of verify everything you download, and you only pull from your own private artifact repository. If you worry about security, that's definitely what you should do. Again, with our team size and resource, that's not our main concern. So we didn't do that, but you should.
The third is, you said about in-app monitoring tools. Those are thought to be in-process monitoring tools because it's exactly what you don't want. To write events for each, I fetch the database, I execute the query, I 1, 2, and 3. So I see that you have two different patterns. One is in-app process that can be only exist inside the container. And third, you want an outside process that monitors your application. And you have two divergent patterns there.
Yes, but I hope, like right now, because we're trying on New Relic, so we have to run within the container to be able, for the New Relic PHP agent to be able to give us all this monitoring, tracking, this metrics. But what I hope to do is, I don't need to install this in-app monitoring tools inside the Docker image. I want to be able to just install on the cluster host itself. So it can just read the Docker run log on the local host. It should be able to give me enough metrics information. If that's possible, then I can save a lot of trouble by need to dealing with, yeah, you have the Docker image that has this in-app monitoring that you don't have in-app monitoring. So if I understand your question correctly, what we have is the trade-off we have to make. Like right now, we do install in-app monitoring within the Docker image. I hope for the tools like Sysdig to be mature enough, then we don't need to do that. And to answer your previous question, I just think about that. So Docker actually make it easier to be able to secure your base image. You don't need to run all this artifact repository by yourself, as long as you make sure your base image, I think that's originally you said, your base Docker image is secure, and you only install your app into that Docker image. That will make the whole thing very secure. And you only need to have a repository for that base image. You have that security. So that's another, I think, advantage of using Docker. All right.
Are you using Docker Compose? Because it looked like it was a bunch of Docker run commands.
So since we're using Docker like AMI, so in the production, there's no Docker Compose. It's only Docker run command. But on our local dev environment, yes, it's Docker Compose. We don't want to run Docker run. We have about 7 services right now. Otherwise, if you don't use Docker Compose, you need to run 7 Docker run commands. That's not ideal. So here's what we have with the stagehand. Let's see. Demo always fail, right? Maybe this is the exception. Yeah, so this is our production-like site, because I fork from master, so it's really what running in production right now. And we can do search. So you can go to search service, you can do search, and you can log in, you can do this. Everyone running on one EC2 machine, and we can create, and we can just click this, and we can just kill that instance. So this tool is very useful for we to communicate this, what we built across the whole team in the company. And it's made possible because it made it a lot easier because of Docker. With Docker, you can build this kind of tool by yourself pretty fast. Okay.
You mentioned you need to run a virtual machine because Docker runs on Linux, I guess, for your OS. Like,
Yes.
do some people say heck with it and just run on their laptop?
You can do that. that would be a lot faster.
It is actually better, simpler if you can, to get away with it. Okay.
Definitely, yeah. I mean, I know a lot of Docker developer, they just use Ubuntu. They just use
So
Linux for
some
their
will
host
just use
machine.
Linux directly.
Yeah, I know some fancy guy. I don't know if you watched the Jessie's talk. So she run this Ubuntu on her laptop, and she Dockerized literally everything. That means it's her Chrome, her the movie player, everything is Dockerized. So she can just have a new Ubuntu and just Docker run can run, and he has another drawback of this is anytime you want to run any command, it's like Docker run something, Docker run something. So she has to go through the trouble to make all this shortcut for her to be able to run. Okay, I want to run Chrome, and I just type Chrome, translate to Docker run Chrome. I mean, yeah, I mean, you feel hardcore, you do that. Really awesome. See someone can do something like that.
Was there a reason why you didn't choose to use Docker Compose on production?
Yes, the main reason is because we don't have Docker cluster. I think you want to. Oh, hold on. Are you saying?
So instead of using like Ansible commands here, yeah, just use Docker Compose. Oh.
We can do that.
Okay.
It's actually easy. So Docker Compose, you need a Docker YAML file. You need a Docker Compose YAML file. We found that actually since we only have this container, and this whole thing will generate, it will be put the correct value by Ansible. It's easier for us to do it this way. Have 3 Docker command, take all these parameters. It's easy to read. I guess the other way is, yeah, I can use this way to create a YAML file on the host. But then the question is, how do you put that file into the host? You kind of like need to echo all these things, generate that into the host. Because you need to remember, Ansible just composed this into a file, and that whole file is launched by the launch configuration. Ansible doesn't talk to that server at all. It uses this whole thing. It uses Ansible ASG module and launch config module to launch this whole thing. So I guess your question is, you have no way to put that Docker YAML file onto the server after this. The only way I can think about is, yeah, here you have a lot of echo command. You echo all this configuration into the file and then run Docker Compose. If you do that, it's not easy to read than this one, I would say. The best way is you can just run Docker Compose on your deployment machine, and Docker Compose can deploy all this service, all this container onto the Docker cluster. I think that's what Docker Compose is, Docker Swarm and Docker Engine they're trying to achieve. We'll know how it goes.
Were you also getting the added benefit of like using Vault to store your secure properties that you're then going to replace in this command? Because like I see like in your Docker run, you've got token equals secret.
Yeah.
Are you using Vault to do that replacement?
No, I did not.
Oh.
So, like I mentioned at the beginning, I'm the guy who's checking out AWS secret into GitHub. I'm ashamed about it. I want to fix it, especially after I listened to Alex Shope's talk. Yeah, we have a plan. We want to fix that. We want to use this secret management service.
Mm-hmm.
That will make things a lot easier. You need to rotate your secret and everything. So to answer your question, no, we didn't do that.
Yeah, or like the other thing is, when you deploy in dev, are you pointing at your production RDS database, or are you pointing at like a local database? Like how are you swapping different configs when you do like a running Docker Compose on your dev server versus what you're running in production?
Yeah, so Docker Compose only run on the dev server, or this the stagehand I showed to you. And Docker Compose, by our way of running Docker Compose, everything running on one machine. So either it's only on your laptop or only on that new launched stagehand EC2 instance. Everything is in one machine. In production, we have Redis as a separate cluster, and we have RDS as a separate service. So we won't be able to use Docker Compose to run in production. We kind of use Docker images in mind, right? So with one EC2 instance, this EC2 instance only run the webpack. Another only run for search service. There's no compose at this point.
Yeah, I was asking like about the environment variables that are different between your environments, like
Yes.
how you're, okay.
Yes, it's different. So in the Docker compose file, for local development, yeah, this is the link name of your service. But here is actually this Route 53 name. Yes.
You mentioned about Docker releasing a new version every month. How does the team deal with that? Is everyone trying to be on the same version? Do you kind of go for a different version each? How does that work out?
That's a great question. So we usually just have a lunch and learn and we did a poll. So we still have people using 1.6 and all the way to people who's running 1.10.2. So I guess it's if you're running into problem, right? If everything works fine, it's up to you. Like you don't care about Docker. You just want to code your Scala. You just want to code your PHP. I mean, it's fine as long as it works. But like, once we update the configuration file that like 1.10, if you have a new, you can use the version 2 Docker Compose version file. If you want to do that, then you need to coordinate to a whole team to be able to. You need to upgrade. And I think it really depends on do you really need to do it. And we have a small enough team that this will be a painful process for us.
Sorry. You mentioned you were using the same ELB when you spin up a new ASG. How do you control which traffic the ELB sends traffic to, or which cluster, like which ASG? Because we use a similar approach, and one of the things we've had a hard time solving is how do we blue-green it like cleanly without, like knowing one group is good before we scale down the whole one?
So what we have is like this, or the process is we're going to launch a new ASG and it will register with the ELB. So we have an exact amount of instance number in that new ASG, and it will register with the ELB. So at the same time, you will have two ASG register to the same ELB.
So traffic is going to both?
Yeah, traffic is going to both.
Okay.
And we will deregister the old ASG out of ELB. And at that time, you will see the auto scaling start to kick in. Like
Okay.
after an hour, we will start to remove one instance and then keep reducing that size. We have about like for our team about a 1 or 2 hour testing. No one yell at us. We know the production is good, so
Okay.
we will kill the old ASG. You can keep that as long as possible, but there's a cost factor you need to consider.
So if you deregister an ASG from ELB, you can't reattach it, can you?
You can.
You can, okay.
Yeah, it's on an AWS instance. On AWS Web Console, you just
Cool.
set up. It's from the, if I remember correctly, it's actually on the ELB level to say what ASG I want to talk to, not on the ASG level.
Cool.
Other questions? All right, thanks for coming.